All right, guys, day 11. We're going to be looking at adding and subtracting fractions. Hopefully this is something that you remember. I know a lot of times we look at fractions and we go, I hate fractions, so therefore we don't want to do them. But this is something that you really have to know, and you will see several problems on the ACT that deal with fractions. So adding or subtracting two fractions with the same denominator, that's easy. You simply add or subtract the numerators of the two fractions and then divide the result by the common denominator of the two fractions. When the two denominators are different, we have to rewrite the fractions as equivalent fractions with a common denominator before we can add or subtract them. Generally what we do is we find the least common denominator, or the LCD, which is something that we've talked about in prior weeks. So let's look at an example. Let's go 1/2 plus 1/2. They have the same denominator, so this one's simple. I add 1 plus 1 is 2. And my denominator stays the same. So this would be 2 over 2 or 1. But like I said, when we get different denominators, that's when things change a little bit. So let's do 5/12 plus 1/4. I do not have the same denominator, so I have to figure that out. I have to change that. They all have to have the same denominator. So like I said, normally what we would do is we would find the least common denominator. What is the smallest thing they have in common? So if I come over here and I list all of my multiples of 4, and then I list multiples of 12, I would see that 12 is the smallest number that they have in common. So I'm going to use 12 as my common denominator. Now here's what I'm going to do. I'm going to ask myself, did my denominator change in the first fraction? It did not, so my numerator does not change. So it would be 5/12. Now I'm going to ask myself, did my denominator change in the second fraction? Yes, it did. So I've got to figure out by how much. So I'm going to ask myself, 4 times what gives me 12? Well, 4 times 3 gives me 12. So because I multiplied that by 3, I also have to multiply the top by 3. So then I get 3/12. Now I have common denominators, so I can add. Remember, my denominator stays the same. 5 plus 3 is 8. I get 8/12. Now, here's what you're going to see. 99% of the time, you are not going to see 8/12 as an answer on the ACT test. 99% of the time, you're going to have to reduce it in some way. So now you need to ask yourself, what goes into 8 and 12? Well, 2 does. Is there anything bigger that goes into 8 and 12? You can say 4. 4 goes into 8 and 4 goes into 12. So I can divide both of these by 4. 8 divided by 4 is 2. 12 divided by 4 is 3. So you are probably going to see 2/3 as an answer on a test. Okay? Subtraction is the same exact way. Alright, subtraction is the same exact way. Let's look at this. 2/3 minus 4/5. Once again, I have to figure out, they do not have common denominators, so I've got to figure out the common denominator here. So 3 would be 3, 6, 9, 12, 15, 18, and then I'm going to do 5, 10, 15, 20. I see that my common denominator will be 15. So, I'm going to come over here, and I'm going to rewrite my problem. I'm going to ask myself, did my denominator change in my first fraction? It did. So 3 times what gives me 15? I'm going to multiply both times 5. 3 times 5 gives me 15. 2 times 5 gives me 10. I'm going to come over here and ask myself, did my denominator change? It went from 5 to 15. So I would multiply both top and bottom by 3, because 5 times 3 gives me 15. So 4 times 3 gives me 12. So I have 10 twelfths minus 12 fifteenths. Now I can go ahead and do my subtraction. My denominator stays the same. And I say 10 minus 12. We all know that 12 is bigger, so 10 minus 12. So I get a negative 2. So my answer would be negative 2 fifteenths. Okay? Let's look at a problem that is a little bit more difficult. Let's look at the problem 7 twelfths plus 3 sixteenths. Now, those numbers are not as user-friendly. Okay? So, let's say I want to figure out what the LCD is. I can list them, or I can also use the method that we learned in doing the prime factorization. Either way, it does not matter. I can list my multiples. Alright, so that's the first 5. 16. And I can stop now because I actually have my first multiple that they have in common, and that's the whole point. So I'm going to see that 48 is my least common multiple. Alright, ask yourself, does it change? Yes, it does. So 12 times 4 gives me 48, so 7 times 4 is 28. 16 times 3 gives me 48, so 3 times 3 is 9. Now I have a common denominator, so I can go ahead and bring that common denominator over. And 28 plus 9 is 37. So 37 over 48. Now remember, these rules are only for addition and subtraction. Alright? Finding that common denominator is the only thing you need to do for addition and subtraction. Alright, what if you were given a problem like this? I don't want to sit and figure out what all this is. I don't want to sit and figure out what 2 squared times 3 squared times 5 is. Okay? I can if I want to, but you're going to see that, and eventually I'm going to have to, but remember we had rules for LCD when we were looking at this type of problem. So, LCD, look and see what they have in common. So they have 2 in common, they have a 3 in common. Alright, so you're going to find the biggest one. So I have, and I'm just going to kind of line these up so we can see. So I'm going to look at this and see which one's bigger. So 2 squared is bigger. I'm going to look at this and see which one's bigger. 3 3 cubed is bigger. And then remember with LCD, I also have to bring down anything that doesn't have a match. So this would be my common denominator, 2 squared times 3 cubed times 5. Well, 2 squared is 4. 3 cubed is, 3 times 3 is 9 times 3 is 27 times 5. Okay? So now I can figure that out. And if I figure that out, I notice that that means that my least common multiple, or the least common denominator, would be 540. All right? So, and see why I mean, if I try to figure all of this out, I'm going to get some pretty big numbers, which is going to take a little bit of time. Alright, so now I figured out my common denominator. Now I need to figure out what I'm going to do with this. Alright, looking at this, then I'm going to say, well, I have to figure this out. This is 27 times 2. This, we said, was 4 times 9 is 36 times 5. Not quite as simple. So let's look and see what we have to do. Well, I've got 2 squared. This originally was 2 times 3 cubed. All right. I need to figure out what I still have to multiply by. I'm going to write this down here so I can see that. Well, I've already got a 2. I've got my 3 cubed, and I've got my 5. So I would actually have to multiply this times 2 times 5 to get everything that's in there. So I need to multiply this times 10. So 10 times 1 is 10. All right, let's look at this. So I've got 2 squared. I need another 3, so I've got to multiply this by 3. 3 times 7 is 21. So now I have that. Much simpler than trying to figure out what everything is equal to. 10 plus 21 is 31 over 540. Guys, all I did here was, instead of looking at 540, I looked at what it broke into on my prime factorization, and then looked at my original. I had 2 here. I needed 2 2's. So I needed to add, to multiply 1. I had my 3 cubed. I needed a 5, so that's what I multiplied by. Over here, I already had the 2 squared. 3 cubed, I needed one more 3, and I already had the 5, which allowed me to see that I needed to multiply everything by 3. Okay? Alright, once we understand how to add and subtract numerical fractions, you can add and subtract algebraic fractions using the same exact technique. So let's look at that really quickly. So let's say that I have 4 over x minus 3 over y. And you're going, but how do I figure out the common denominator here? Well, the common denominator would be x, y. Because they're not numbers, I have to make sure I have both of them. So the common denominator is going to be xy and xy. Now ask yourself, how did it change? Well, if I already have the x, I need to multiply it times the y. So to get xy, I need to multiply times y. So this would be 4y. I have xy. I already have the y. I would multiply everything times x. So I get 3x. Now here's the difference with these types of problems. Normally, we would go ahead and add across. Guys, I cannot add because 4y and 3x do not have the same variable, so they cannot be added together. But I can rewrite this. You can actually rewrite it like this if you would like, or you can leave it like this. But it can be rewritten in this form. So it would be 4y minus 3x over xy. Okay? If you have questions, guys, make sure you ask.